Hi everyone. Thanks for coming. I'm Lukas, and I'm going to talk about this topic called Techniques for Reliable Code Generation Using AI Agents. So, in general, this talk is for people who maybe have been using some AI coding agents such as Claude Code or Codex, but haven't yet had the chance to look into techniques to kind of create longer running workflows to automate parts of their work. So we'll be talking about some of the kind of underlying principles of why some approaches to that maybe work and some others don't. But before we get started, let me kind of introduce myself and kind of explain from which perspective I've been thinking about this. I've joined Mercari in 2022 as an Android engineer and have been mainly working on the design system and kind of mobile architecture teams. And in July of this year, I joined the AI Task Force, which is a project to promote AI usage across the company. Where, now I'm looking into kind of how to apply AI in development processes, mainly feature development, mobile feature development. So my perspective in this talk mainly comes from two projects that I've worked on during this year, which is, one is before I started working in the AI Task Force, I had the chance to use LLMs to migrate our code base to a new design system that we had just written. This was kind of before we even had agentic AI. So I just ended up using OpenAI's kind of chat API to do that. Since then, of course, our life has dramatically changed. We now have all these coding agents, Claude Code, Codex, whatever. And now, within the AI Task Force, I'm looking more into kind of how to accelerate feature development. Obviously, this agentic AI is naturally the basis for that now. Recently our focus has been on something called spec-driven development, which I think Kimura-san talked about in his talk before now. Both of these problems have in common that we're kind of talking about some sort of reusable workflow, reusable agentic workflow that needs a lot of information to run successfully. So, for example, you have some library migration that kind of requires rules on how the migration should be done. So, for example, in the design system, you want to replace some UI component A with a new UI component B and C. On the other hand, feature development obviously takes even more information, which is what kind of features should be implemented, but also how it should be done. Especially on mobile, we kind of have a lot of architectural guidelines and patterns that should be used. I guess what you're going to ask yourself is, why we just have this Claude Code, it takes a lot of information, we can attach all kinds of things, so we can just let it run, right? But probably everyone has run into some of these problems that it usually doesn't work so well. In summary, I think we need something different, which is we need some sort of agentic workflows that generate code that is ready to be merged. So kind of writing tests and following best practices and kind of technical guidelines are all part of kind of the requirements that need to be fulfilled for that. So the question is, how do we get there? So in the remaining 15 minutes of this talk, I don't think we'll solve everything like this, but I want to talk a little bit about some of the things I've learned in the projects I've worked on. And ultimately, I think when working with AI agents based on LLMs, we deal with some sort of non-deterministic system. So I don't think there's any silver bullets to solve this problem, but we just have some techniques to kind of increase our chances of success. With that in mind, I want to talk about three different areas. First, let's talk about why kind of this naive approach fails and what to do about that when approaching the problem. Second, I want to talk about another potential source of failure, which is the runtime environment of an agent. So, or more specifically, kind of what to keep in mind when agents use the tools that they are provided. And finally, I want to shortly cover some thoughts about how to test these agentic systems that we're building. If we start to have more and more these kind of workflows that autonomously write code for us, we need ways to test them, since I think they will just become part of the infrastructure that we build as a company. So let's get started and go back to what I mentioned earlier. Why do these naive approaches of just attaching a lot of information to a single prompt often fail? The simple answer is that LLMs don't perform that well when given too much information at once. So we often hear about kind of the context window size when it comes to limits of the amount of information an LLM can handle, but the amount of information it can actually take in to perform a task reliably is a lot less than that. The most kind of apparent example for that comes from when I first used LLMs to kind of migrate code. I had some prompt that would migrate code to a new design system, and it had some information attached about how to migrate, let's say, 2 to 3 components. And it worked really well and no problems. But unfortunately, the API surface of the design system is pretty big, so I kept adding these migration rules, describing how the code should be replaced. But after about like 10 or 12 components, things started to fail, and even stuff that worked beforehand stopped working. So like at that point, like the LLM just made up some of the migrated code, some of the parameters maybe of new components, even though it knew about how the parameters should be named. So ultimately, yeah, if a lot of information is given, the LLM will start ignoring parts of the prompt. So yeah, when you approach a problem that should be solved by an AI agent, I think the first question to ask yourself is like whether this can actually be solved in a single prompt. If it can't, you'll need to think about how to split up the work into different subtasks and then of how to coordinate that process. So kind of what we're looking at after is some sort of decomposition of a larger problem into smaller parts that can then be solved with a lot less information each. Once like each smaller part is solved reliably, they can kind of just be pieced together into a bigger workflow. Each of these smaller tasks then kind of should be solved in a separate context window. Just simply kind of making a list of tasks to work on one by one is usually not enough. So yeah, once we have that set up, kind of we can essentially profit from two effects, which is, first of all, less context is needed to instruct the agent, and less context is accumulated when it's working autonomously. This kind of by itself will increase the chances of success. But it allows us also to have a little bit more control over kind of later steps in the workflow. For example, yeah, if you just had a single big task to an agent, if you give that to an agent, let's say steps 1 to 5, by the time the agent's working on step 5, it kind of accumulates a lot of kind of unrelated context to that step. So once it's working on that, it might have forgotten some of the information that you've given it to that would actually help solve that problem. So kind of as a secondary effect, you kind of get more control over the information that is used for that step. Yeah, essentially starting with a clean slate, you can fully control the information that is given for that. So yeah, how do we decompose the problem into smaller tasks? That is something that from my experience depends a lot on the task at hand. So for example, when migrating libraries, like I talked before, it's often possible to just work in iterations, kind of replacing different parts of the API surface within kind of each subtask. If you're using Cloud Code, for example, you can probably write some sub-agents for that. Each would have a different context window, and then you can coordinate it from a / command, for example. Another approach that we now see in frameworks for spec-driven development is to work on kind of a big problem in 2 stages. First, kind of do some research around the current code base and kind of let the LLM decompose the problem. And second, take each of these kind of decomposed problems and then let the LLM implement it in a separate context window. So yeah, once the problem is split into smaller tasks with an appropriate size, we can ideally just let the agent do its work autonomously. While the agent is working, it will use tools to interact with its environment. So yeah, for example, to like read files, write files, fetch additional information from somewhere, fetch some data. A lot of these tools are obviously provided by a coding agent already, but you've probably also used some MCP servers or something like that to add additional ones. Now, the first thing that I think you want to do is to kind of review what tools the agent calls and what data it receives back. This way, you can like understand what the agent is doing and why, which can give you some hints on how the prompt should be structured. Yeah, the other thing is that I think you should think about which data and which tools are actually necessary to solve a specific task, because it allows you to narrow down the amount of tools that the agent is able to use. In general, like if you instruct some coding agent to do something, it will not just send the prompt to the LLM, but a bunch more information, like whatever you have, for example, in your agents.md file, but also all like a list of tools that are provided to it, including like their descriptions. So limiting the available tools can both kind of reduce the amount of irrelevant context that is passed to the LLM, but also kind of guide the agent towards using the right tools with the right parameters. Yeah, recently I had a very obvious example for that, where this was kind of very useful. I was working on some like code review agent, and which would fetch like a pull request diff from GitHub and then review it using some guidelines. Now, like although the agent knew about the pull request number, it would sometimes fetch like a diff of completely unrelated PR and then comment on them, which is like obviously not what we want. So yeah, limiting Cloud Code to only being able to fetch that diff of specific PR fixed this, and after that kind of the review agent always got the right PR diff to review. Aside from being necessary to solve a specific task, tools can also serve as more of a self-correction mechanism for an AI agent. Like building the code it has written, like running test cases, linting, or even some sort of like AI code review can all be seen as kind of examples for that. Coding agents often employ some of these mechanisms automatically these days, but you can also think of kind of adding your own ones if you run into some problems. For example, to review code that the agent has written. However, I think the thing to take care there is that these self-correction mechanisms, they need to return some sort of easily understandable error messages. This kind of would, of course, be good for humans anyway, but for AI agents, it's even more important. For example, I've experienced some cases where the AI agent had written like a lot of code and it was pretty much correct, but it forgot, let's say, some annotation for a test class. But then, once you run the test, it gets some non-descriptive error message back, which led to the AI agent just deleting the whole test suite, which is obviously not what we want. So if there was a better error message about that, it would have been able to fix that. On top of that, like some of these feedback mechanisms also add a lot of unnecessary information to the context. For example, on Android, we have this build system called Gradle, which is, it just once you build something, it prints out like thousands of lines of status messages, which is costly because it takes a lot of tokens, but also kind of contributes to the amount of information the LLM has to process in that single context window. So filtering out these status messages or kind of running builds in a different sub-agents, both of them can kind of help you keep your context window clean and then increase the output quality. And finally, I want to talk briefly about testing, which is, this is not about like writing tests for kind of the code that the AI is writing on your behalf. That's kind of a given already. That's what should be in your prompt. But this talk is about like building some sort of like small agentic systems that produce code, right? And those systems, they should be tested too, just kind of like any other software system. The main difference between like agentic systems and traditional software systems is that, we now have to deal with a lot more like non-determinism. So specifically, the code produced by your system will be different on every run. While this introduces some like complications to the testing process, and we'll talk about that a little bit later, it also makes testing even more important, I think. Like any other software system, tests are important to check for regressions. For example, like if you decide to change like the model that's used in your workflow, or edit the prompt, or provide some new data. But since you're dealing with a non-deterministic system, they'll also be important during the development phase when you're kind of trying to increase the reliability of your workflow. If you cannot measure how often your workflow produces a good result, and then you kind of not know which techniques that you've applied to optimize it are actually increasing your chances of success. And to measure that success rate, you'll need these automated tests that can kind of run many times and give you some feedback on that. In the context of agents, that's typically called evaluations, these automated tests. In general, I think the term has a bit of a broader meaning, but for the purpose of this talk, let's focus on kind of how to do this like automated testing for non-deterministic systems that generate code. So to speak more concretely, we want to test for a specific prompt that the generated output is correct to some degree. Since the prompt is always the same, we also expect that the output fulfills a number of criteria, right? So, or more specifically, we expect that the output follows the knowledge that is encoded in the agentic workflow that we've written. Because of this non-determinism, we cannot just assert against a set value like we do in unit tests. The output will be like slightly different on each run, like I said before. So if we did that, the test would never pass. But we kind of need to think about different ways on how to judge the generated output in a different way. The appropriate way, again, depends a little bit on the task at hand. So like if you look at some like LLM benchmarks for software engineering, for example, they often supply a set of unit tests to test the generated code. However, when the AI agent is like kind of tasked to write the unit tests themselves, or where the quality of the code output matters, that kind of is not going to work by itself. What I found works quite well for these cases is another common strategy to test AI systems, which is to use another LLM to judge the output of the system. Since like the given judgment criteria are very specific to the test case, to like the specific prompt that you've given it, they're kind of concrete applications of the more abstract knowledge encoded in the system. So because of that, it works surprisingly reliably. Yeah, aside from choosing kind of the right judgment criteria, the other problem with testing code generation currently is that, I'm not aware of any like frameworks doing this. So but luckily we kind of live in some great times where we have these coding agents and they can actually help us write our own framework if we want to. So we can, for example, we can get a pretty well working one with the combination of tools that we kind of use day to day anyway. Coding agents, they often write the output to disk, which kind of creates some problems with test separation. So if you have some workflow and you want to run like 5 of them in parallel and they all touch the same file, you obviously can't just do that in your Git checkout. We can essentially use Git work tree to spin off a version of the current code base for each test case, so you can have this test separation working. The testing framework then will have to trigger some sort of like your agentic workflow. If that's kind of implemented in Cloud Code, you can just like run a prompt by passing it as a CLI parameter in print mode without having to enter the interactive mode. So other coding agents, they typically support the same. So then your workflow would be running. And finally, when it's finished, you can use this like LLM judge to judge the output. Personally, I've used this like G-evil metrics of a framework called Deep Evil for that, which can essentially score your code output based on a set of criteria that can be specified in each test case. Using all these tools, you kind of end up with some sort of like testing framework that can help you measure the reliability of your agentic coding workflow. So in summary, the main 3 things that I've learned from working on agentic systems that write code are the following. It's important to think about how to decompose the problem into appropriately sized chunks that can be handled in separate context windows. It's important to review how the agent is interacting with its environment. And finally, having evaluations to measure reliability and correctness helps a lot when optimizing systems. Thank you.
ルカスさん、ありがとうございました。Please step down from the stage.